All right, so picking up where we left off, we are on example 3, and the information that it gives us is sine of theta is 3/5, and theta is between 0 and pi over 2. So this tells us that it is in quadrant 1. Now, we already found sine of theta over 2. We just used our half angle identity, right? So sine of theta over 2 is equal to plus or minus the square root of 1 minus cosine theta divided by 2. So we're going to do something really similar here. To find cosine of theta over 2, it is equal to plus or minus the square root of 1 plus cosine theta over 2. So let's go ahead and write that. So cosine of theta over 2 is equal to plus or minus the square root of 1 plus cosine theta over 2. Now in this case, we know that it's going to be plus because cosine is positive in quadrant 1. So we're going to go with the positive version of this. So I actually already found cosine of theta over here. So this turns out to be the square root of 1 plus 4/5 over 2 is the square root of 5/5 plus 4/5 over 2 is the square root of, let's see, 9/5 over 2. So this should be the square root of 9 over 10 is equal to 3 over root 10. And that is what we get. All right, so the general idea is that we just used the half angle identity above, and because we already knew what cosine of theta was, we just plugged it in and then simplified it. All right, how about tangent of 2 theta? So I'm going to go up and find my equation for tangent of 2 theta. Let's see, where was that? So 2 tangent theta minus over 1 minus tangent squared theta. So this is tan of 2 theta equals, just want to double check, we have 2 tangent theta, 1 minus tangent squared theta. 2 tangent theta over 1 minus tangent squared theta. Now, in this case, do we know what tangent theta is? Well, I'll go back to my triangle. Where did that triangle go? Oh, that was in an earlier problem where we drew the triangle, but it's the same triangle. So this is my theta. I am in quadrant 1, and the opposite is 3, and the hypotenuse is 5, and the adjacent is therefore 4. So tangent is opposite over adjacent, so that means that tangent of theta is equal to 3/4, right? Let's double check that. That is the opposite over the adjacent. We're in a good place. All right, so now we can just start plugging stuff in. 2 times 3/4, 1 minus 3/4 squared. The top becomes, let's see, this would be 6 over 4 is 2, well, this is just, 3/2. And then this is 1 minus 9/16. And so this is 3/2 over 16 over 16 minus 9 over 16. And we get 3/2 over, let's see, this is 7 over 16. So this is 3/2 times 16 over 7. And let's see, this can simplify a little bit. So I'll rewrite this as 3 times 8, 3 over 1 times 8 over 7. And this gives us, what, 23 4/7. All right. So now we'll do tangent of theta/2. We're going to do a pretty similar thing. And we're going to go over here and say that tangent of theta/2 is equal to, in this case, we're going to use the positive version because tangent theta is positive in quadrant 1. So we have tangent of theta/2 is equal to the square root of, let's double check, 1 minus and then 1 plus. And this ends up being the square root of 1 minus, we found cosine earlier, it was 4/5 over 1 plus 4/5. So this is square root of 1/5 over 9/5. And so this is the square root of 1/5 times 5/9. 5's cancel, so this is 1 square root of 1/9. So this is 1/3. Now, does this make sense? Well, we can do an alternate method and say, well, phi is theta/2. Then we know that tan phi is equal to sine phi over cosine of phi. All right, well, what was sine of phi, or theta/2? Was 1/√10, and cosine was 3/√10. So you end up getting 1/√10 over 3/√10 is equal to 1/√10 times √10 over 3. Root 10's cancel, and you're left with just 1/3, which is what we got using the other method. So either way, we are good. Now, at the bottom, we have just a summary of our double angle formulas, our half angle formulas, and then this half angle formula is equivalent to what we have above. You'll find all 3 in your book, but this is another useful, I guess we have 3 half angle formulas for tangent of alpha/2, right? There's these 2, but then of course we have the one above. So that's it, and if there are any questions, let me know.